In the same way that we verbalized the product rule for derivatives, we are going to verbalize the quotient rule for derivatives. As we said before, if we have a function that is defined to be some mathematical operation, here that mathematical operation is division, that is a quotient, that's why this is called a quotient rule. If h of x is defined to be the quotient of f of x over g of x, when I find h prime of x, I must apply the quotient rule for derivatives. The quotient rule has several pieces. The easiest way to apply the quotient rule is to verbalize it. So let's verbalize what we have here. If g of x is our bottom function and f of x is our top function, now we're not using 1 and 2, we're using top and bottom. The derivative h prime of x would be the bottom function as they gave it to us, that's bottom, d top, so times the derivative of the top function, minus, now there's a minus sign in the quotient rule, top, the top function they gave us was f of x, d bottom, so times the derivative of the bottom function, over all of that, all of those terms divided by bottom squared. So the bottom function and the whole bottom function as they gave it to us squared. There is the quotient rule for derivatives. If you have a function that is defined to be the quotient of two other functions, this is how you are going to find the derivative. And the easiest way to apply all of that, because our mind is not built for symbols. If I tell you the derivative of h of x is g of x times f prime of x minus f of x times g prime of x over g of x squared, your brain doesn't really get that. Your brain is built to understand language more than symbols. So we try to turn things that are symbol intensive, and this formula is, into language because our brain can deal with that much better. Bottom d top minus top d bottom over bottom squared. You're going to be able to apply the quotient rule months from now, and more importantly, you're going to be able to apply it on a function no matter what your quotient looks like. This is in general. F of x can be any type of function. G of x can be any type of function. It doesn't matter. So let's work some examples. Find f prime of x for f of x equals, here's a function in the numerator, x squared minus x plus 1, and a different function in the denominator, x squared plus 1. So we're going to use the quotient rule, and we're going to apply it by verbalizing. The verbalization for the quotient rule is bottom, d top, the derivative of the top function, minus top, d bottom, over bottom squared. And there, I have found f prime of x, and done it very quickly and concisely. I don't have to remember, okay, what's first? Is it f? Is it g? Is it f prime? Is it g prime? I remember what's first. It's bottom. That's g. What's next is d top. That's f prime. Minus top. That's f. D bottom. G prime. Over bottom squared. G of x quantity squared. So verbalize these rules when you apply them, and it makes them much, much easier to deal with. Now, we do have a quotient. This example says find f prime of x for y equals, but in the numerator we have a product. But wait a minute. Can we apply the product rule and the quotient rule together at the same time? Yes, we can. We're going to be able to apply multiple differentiation rules all in one function. The key is understanding when to apply which specific rule. Now, f prime of x is equivalent to y prime. It's just alternate notation. They gave me y equals, so I'm going to use y prime. This is a quotient. I'm going to use the quotient rule. The quotient rule says bottom. Then it says d top. But top is a product. In order for me to find the derivative of the function that is in the numerator, I must apply the product rule, because the function that is in the numerator is the product of two other functions. If we were going to go back, we would call, let's call y k of x. That would be h of x times, let's just use different letters, L of x over M of x. We have a product in the numerator, so when I have d top, I'm going to have to use the product rule for derivatives. So make sure you can see when you might have to apply another derivative rule inside of an ongoing derivative rule that you're taking. So I need the product rule in the numerator. The product rule is, now I'm dropping the quotient rule because I'm not using it for this piece, but I'll come back and pick up the quotient rule and finish what I'm doing. So bottom, now I need d top. D top is 1 d2 plus 2 d1. Now there's bottom d top. Now it's minus top, copied down just as they gave it to me, so bottom d top minus top d bottom, all over bottom squared. There is the derivative for the original function y. As you can guess, the more derivative rules that we learn, the more time-consuming and potentially complicated finding the derivative function is going to get. So learn these verbalizations. You have seen me apply the product rule correctly because I verbalized it, 1d2 plus 2d1. And the quotient rule correctly. I'm not missing any pieces, and I don't have any of the pieces in the wrong place. I have them exactly where they belong because I have memorized bottom d top minus top d bottom over bottom squared. Now the burden to know those is on you.